Welcome to Master Concepts in Chemistry. In this lesson, we're going to discuss how to calculate the mass of a compound present in a certain amount of molecules of the compound. So what is the question? So here's the question. So the question says, what mass of glucose is present in 6.68 times 10 to the power 21 molecules of glucose? So they want us to calculate mass of glucose in this amount of molecules of glucose. Okay. So to solve such a problem, what you need to recall is you have to recall the relationship between mass, moles, and molecules. So I'll write a relationship here. So I'll say mass in grams is connected to 1 mole, and 1 mole is connected to molecules. So here, as written, we are traveling from left to right, from mass in grams to molecules. But the question says, what is the mass present in a certain amount of molecules? So meaning we have to travel from right to left. So we have to travel from right to left, so in this direction. So to go from molecules to moles, what do we need? We need a conversion factor, and this conversion factor is the Avogadro's number. And because we are traveling from molecules to moles, we have to flip the Avogadro's number so that we'll have the right form such that molecules will cancel out and leave moles. So we all know Avogadro's number is 6.02 times 10 to the power 23 in 1 mole of a substance. Okay, so we'll write 1 mole on top and Avogadro's number of molecules at the bottom. So this is the form in which we would write our conversion factor to go from molecules to moles. So now that we have moles, that's not where we want to end. That's not where we want to end. We want to end at mass. So that means that we have to use another conversion factor. And luckily, the conversion factor is molar mass. But here, we want moles to cancel. So we just use the molar mass in its original form, which is grams per mole. So I'll write molar mass here. Grams per mole. Okay. But because our substance is glucose, we have to find the molar mass of glucose. Okay, so that is the key thing you have to recall. Okay. Now, glucose is written in text, but the chemical formula is C6H12O6. In problems like this, they always give you the chemical formula of the chemical, so that in case you don't know what it is, you have it provided. So you use it to calculate the molar mass. Okay, so yeah, so that is the chemical formula for glucose. Okay. So we have our Avogadro's number. Now we need to find our molar mass. And glucose is a compound. It consists of different atoms united to form it. So we have to find the molar mass of the whole thing. We just can't look on the periodic table and just find the molar mass right there. We have to do some multiplication and addition. So let's go ahead and find the molar mass of glucose. So molar mass, all right, MM, capital M, lowercase m, which stands for molar mass of our glucose, C6H12O6 is equal to. Now, as you can see, we have 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. So to find the molar mass of the 6 atoms in this glucose, we have to multiply the 6 by the molar mass of carbon. So we'll say 6 times the molar mass of carbon. And when you look on the periodic table, the molar mass of carbon is 12.01. Okay, so let's go back. So right, times 12.01 grams per mole. Then we'll close the parentheses, then we'll add plus. Then we'll move on to hydrogen. We have 12 atoms of that. So we'll say 12 times the molar mass of hydrogen. So let's go back. So the molar mass of hydrogen, so hydrogen HCl, look at where my cursor is 1.01. So we go back and write 1.01 grams per mole. Then plus, we move on to the last, which is oxygen. We have 6 atoms of that. So we'll say 6 times the molar mass of oxygen. So oxygen is over there. So 16.000. So we write 6 times 16.00 grams per mole. So you see, so we multiply and add everything. So once we multiply this, we'll get 72.06 grams per mole. Plus, once we multiply 12 by that, we'll get 12.12 grams per mole. Plus, once molar 6 by 16.00, we'll get 96 grams per mole. And when we add everything, we'll get 180.18 grams per mole. So now we have our molar mass of glucose. So what we need to do is we proceed to solve by plugging in our values in our table. So let's draw a table. So remember, we are given a certain amount of glucose in molecules. So we write that here, top left corner, which is 6.68 times 10 to the power 21 molecules glucose. So C6H12O6. And remember, to go from molecules of glucose to moles, we have to use Avogadro's number. But since we want moles, moles should be on top. So we'll have a mole on top, and then we'll have our molecules at the bottom. But remember, molecules goes with Avogadro's number, and then 1 goes with our mole. So 1 here, and then Avogadro's at the bottom. 6.02 times 10 to the power 23. And remember, we're calculating for glucose. So C6H12O6, C6H12O6. Then we'll close our table. So as you can see, molecules will cancel molecules because they're on the diagonal. And as I said before, in some of my videos, I said the horizontal line, it's division, considered as division. And then the vertical line is multiplication. Okay, so since you have molecules on top and molecules at the bottom, basically they are dividing, so they cancel each other out. So now we have moles, but we don't want to end at moles. We want to end at grams. So now, with our table, we are here now, but we want to go all the way to mass. So what do we need? We need a molar mass to go from moles to mass. So since we want mass, the top here should be grams of glucose, C6H12O6, and the bottom here should be moles of glucose, C6H12O6. So our molar mass is 180.18 grams per mole. So 180 goes with grams, and 1 goes with that. So we'll close the table. So units on the diagonal will cancel. So once we multiply the top numbers together divided by the bottom number, we'll get 1.9973 grams. Now we have to make sure we report our answer to the correct number of significant figures. So we have to look at the numbers we have and also the one that has the least number of significant figures. So if we look, grams, here the mass has 5 significant figures. 1 and 1 have infinite number of significant figures because they are definitions. And then Avogadro's number has 3, and then the mass and number of molecules has 3. So that means that our answer should reflect 3 significant figures. So our first significant figure is 1, second 9, and then third the second 9. So this is where we are supposed to end with our answer. Now the next value is greater than 5 because 7. So we round it up as 1, add it to the next. So we add it. Round as 1 added to 9 is going to be 10, and when we take the 1, we write 0 and take the 1 and add it to the next 9, 0, and then we'll add it to the 1 here, so 2. And remember, there's a decimal point, so it's 2.00 grams. So this is to trace some kind of figure. So remember, when you have a number, decimal point, and zeros, the zeros are significant. Okay, so yeah, again, our answer is 2.00 grams to trace some kind of figures. Okay, so thanks for watching.